Hello boys and girls, welcome to the Math Club. In this video, we're going to talk about independent events and using tree diagrams to show independent events. The key point here says two events are independent if one happening does not affect the probability of the other. For example, flipping heads with a coin has no effect on rolling an even number with a dice, so they are independent events. So the meaning of independent events, it means that they don't depend on each other or they don't depend on each other's outcomes. So basically the outcome of one of them doesn't change the outcome of the other. We're going to use the tree diagrams and talk about independent events. Now, how do you know that these events are independent on the tree diagram? You can see that the probability doesn't change from the first event to the second one. The probability stays the same if they are the same thing. For example, if I'm rolling or if I'm flipping a coin and I got heads the first time, and the probability of heads will be 1 over 2, the second time I flip a coin, the probability will stay the same. So it doesn't change. This is the meaning of having two independent events. Now let's take a look at a question and we will understand more how to use the tree diagram to talk about independent events. Question 6. At a school feat, these balls are placed in a basket. If you pick a ball with 20p on it, you win 20p. A player chooses a ball at random, then replaces it. Then she chooses another one. Now, as you see from the question, the word replaces it. It means that these events are independent because she didn't keep the ball. She puts the ball back. That means that these two events or these two tries are independent. Now, let's continue. Question A, copy and complete the tree diagram to show the probabilities. Now, as you can see here, we have 8 balls. 2 of them, they have 20p's on them. Good. Now, let's take a look at the tree diagram. Let's finish it, complete it, and then we will start answering the questions. First thing, let's fill the gaps here and here. As you can see, we have 20p, so the same is here, 20p. Good. And here we have not 20p, so same idea here, not 20p. Good. Now we filled the gaps. Now let's fill the probabilities so we can answer the questions. Now the first ball that you picking 20p out of these balls is 2 out of 8, right? So 2 over 8. And when you simplify it, it's going to be 1 over 4. So the idea here, they simplified it so you can know that it's 1 over 4. But it's basically 2 over 8. Now, it's okay to work with both numbers or simplifying the numbers. It's not a problem. But let's work with the big number, which is 2 over 8, okay? Let's make this 2 over 8 so you don't get confused about answering the questions. This one is 2 over 8. And then picking the other one, which is not 20p, is going to be what? It's going to be good. It's going to be 6 out of 8. So we write 6 out of 8. Now, same idea here. We're not gonna use this, okay? Let's make it with fractions without simplifying, so we don't get confused about the answers. Now, if you pick the first ball and you don't keep it, it means the probability will stay the same. This one will stay the same here, and this one will stay the same here. So, when we write it, picking a 20p will be 2 over 8 again, and not 20p is gonna be 6 over 8. Good. Same idea here, 20p 2 over 8, and not 20p, let's put it here, not 20p is going to be 6 over 8. Good. So like this, we finished and we filled the gaps of the tree diagram, and we understand how we answered these probabilities. And as you can see here, because these events are independent, so the probability of picking a 20p at the first time is the same as the second time. And same idea for not picking a 20p, 6 over 8 is going to be the same for the second time. Now let's take a look at the questions and start answering them like one by one. Now question B, what is the probability of first winning 40p? Now winning 40p requires picking 20p in the beginning or the first time and 20p at the second time. So basically following this line here, 20p at the first time and 20p at the second time to win a 40p. Now, if you follow this line, you will have two probabilities in these lines. So what do? You take them and multiply these probabilities. So you multiply this by this. So 2 over 8, you multiply it by 2 over 8. Now let me move this. So as we said, to win a 40p, you have to win 20 at the beginning and 20 at the end. So we multiply the probabilities, which is 2 over 8 by 2 over 8. And it's going to be what? Let's do it here. 2 over 8 multiplied by 2 over 8. And the answer will be, we multiply the ones on top, it's going to be 4. Good. And then we multiply the ones in the bottom, or the denominator, it's going to be 8 times 8 equals, let's do it with a calculator. Yes, you can use the calculator here, it's okay. And you can find the answer and write it on each other. Now let's multiply 8 by 8 and then come back. So 8 times 8 equals, very good, 64. Now let's go back. So the answer is 64. Good job. Because we're going to use it here all the time. So 2 over 8 multiplied by 2 over 8 equals 4 on 64. You can keep it like this or you can simplify it. As long as you have the right answer, it's okay. It's not a problem. Now, winning 40p's chances or probability is 4 over 64. Very good. Now, the second one says winning nothing. So winning nothing, you have to follow which line? Very good. You have to not win 20p's at the beginning or the first try and not win 20p's at the second try. So you just multiply the probabilities of not winning the first one and not winning the second one. So 6 over 8 multiplied by 6 over 8. Now let's write it here. So 6 over 8 multiplied by 6 over 8. And the answer will be, very good, 36 over 64. So this is the probability of winning nothing. And as you can see, the probability of winning nothing is more than winning 40p's. And this is very important to understand. So winning nothing is 36 out of 64. Very good. Now, as I want you to understand what we do, we follow the lines because we have 2 tries. You can't use the first one only. Now, for winning nothing, we followed this line, winning nothing at the beginning and winning nothing at the end, or the second one. And we multiplied the probabilities of both of them, and we got the answer, which is 36 out of 64. Now, let's talk about number 3. In number 3, he said, winning with the first ball, 20p's, and losing with the second ball. So winning the first ball and losing the second ball. So which line do we follow? Very good. So winning the first one here and not winning the second one. So we take the probabilities and multiply them. This is very easy. We just follow the rules of the question and we multiply the probabilities that we have. So 2 over 6 multiplied by 6 over 8. Now let's write them and multiply them. Let's use this. So 2 over 6 multiplied by 6 over 8. And the answer will be, very good, 12 over 64. Very good. So winning the first ball with 20p and not winning with the second ball, chance or probability, is 12 over 64. So you have a 12 over 64 chance of winning the first ball and losing with the second ball. Now let's take a look at the last question. Winning 20p. Here, when he says winning 20p, it might be from the beginning or the first ball or the second ball. So in this question, we're gonna find the probability of winning with the first ball and losing with the second one, and then losing with the first ball and winning with the second one, and then we add them together. Now let's first follow the winning of the first one. This one is the winning of the first ball and then losing with the second ball. We take the probabilities and multiply them, and then we find losing with the first one and winning with the second one. We take the probabilities and multiply them, and at the end we add both of them. This is how you answer this question, because he didn't say winning the first try or the first ball or winning the second ball. He said winning 20p wherever it is. So you find the probability of winning the first one, losing the second one, and then find the probability of losing the first one, winning the second one, multiply them by each other, and then add both of them together. Now let's do it together. Let me remove this. Keep this so we can understand what are we answering. Okay. So let's move this. Yes. So let's talk about this times this and this times this. They will give you the same answer, which is 12 over 64. You just have to add them together. Now let's remove this and write it here. So the answer of the last one, we say it's 2 over 8. Let's put it in brackets. Yes. 2 over 8 multiply 6 over 8, and then you add it to 6 over 8 multiply 2 over 8. So basically this one is 12 over 64, and this one is the same, 12 over 64. So we just come here and write it so we can add them together. 12 over 64 plus, let's put it here, 12 over 64. And the answer will be, very good, 24 over 64. And this is the probability of winning 20 Ps. And it doesn't matter, is it the first ball or the second ball. So basically you have to focus on having an independent events in the tree diagram and how to use the tree diagram to find or answer questions about independent events. And you have to focus that they are independent because he said first replace it, so it means put the ball back, and because of that the probability from the first ball didn't change from the second ball. And this is how you answer a question like this. Thank you very much for watching. See you next time.